yeah, Florian, you got take it from here. The stage is yours.
Perfect. Okay, so let me share my screen, and I will do a quick presentation about myself and MusicLang and our project. And then also I will do a quick demo of our models. So happy to be here, quite excited to talk about MusicLang today. So anyway, feel free to interrupt me if something is not clear in my presentation, if you have any question, of course. Okay, so I'm the CTO of MusicLang, and so MusicLang is about so music generation, and more precisely about bringing some controllability over the symbolic music generation. So a little agenda of our talk today. So I will present myself quickly, why I built MusicLang, how it started. We will do an overview of music generation, mainly focusing on the two different kind of models that are out there that are very fashionable. That's symbolic models versus audio domain models, in fact. We will then deep dive on MusicLang about our two main models that are based on composition and arrangement. Finally, we will discuss about the recent open source models that we have released, which is a music continuation models. And finally, we'll of course show a demo of some songs that were made with MusicLang. So let's go, and then of course we can discuss what is next for us and answer all your questions. So I'm Florian Gardin. So as I said, I'm the CTO of MusicLang. I'm from Paris. So yeah, sorry for my English. And so I'm a musician and a composer. I compose many songs for video game mainly. So that's my specialty. I'm more versed into orchestral music, for example. I am also a data scientist and software engineer. I have a background of computer science and engineering. I'm really specialized in signal processing. For example, I did some projects about emotion recognition and stuff like this. But I always like this wish to do something around the music industry and to link artificial intelligence, data science, and algorithmic music. So the story behind MusicLang is not really complicated when you know that. It's like I always use a lot of algorithmic composition methods in my composition work. So simple algorithms like really optimizations to get some voice leading, some chord progression generation, or stuff like this. So really quite simple stuff. And I had this long project of mine, which was to build really a Python library for writing music in a programmatic way, which was helpful. So it was about, for me, I started this project like 5 years ago. And it was for me a project to help me compose music faster, for example, by manipulating the music, by doing automatic modulation, transposition, and developing some rhythmic ideas and stuff like this. So I built this language at this point. And so two years ago, in 2022, end of 2022, I decided to go full power on it. So yeah, I started to develop this open source project and to release it to the public. At the same time, there was a big wave of artificial intelligence models that were coming up, basically all the diffusion models and the LLMs. And so because I was also a data scientist at this time, I tried, in fact, to train a transformer on this language I've created. And that's basically how MusicLang was born. Really to teach a transformer to write some MusicLang language code. And so the combination of both ideas gave really what I call a controllable generative model. It's like, because the language in itself is very controllable, it's like you have to specify your chord progressions, the melodies, the instruments you put in there. Really, it gives something that we call controllable. And I will, of course, come back to this idea later. All right, so quickly, so I will introduce, for those that are not really familiar into the music generation world. Really, I try to go quick on that, but there are really two separate ways of generating music currently. So there are many work in the audio domain generation. That is, you are working with the raw 1D signal of audio. So the list of companies or algorithms that are doing that is, of course, not exhaustive. But for example, you saw recently Music Gen from Meta. You also probably saw Google MusicLang, which is closed and not yet released, but that's the same idea behind it. And there is another way, in fact, to generate music, which is, I would say, closer to the way artists currently make music. It's like we're working on the symbolic domain generation. So I'm really here focusing about composition, and how to do composition. So there is, for example, MuseNet from OpenAI that did symbolic music generation, but it's not available anymore. And of course, so I put MusicLang here because we are really a model of symbolic domain. So I would say they are very different. And they don't lead to the same thing. So, for example, audio domain generation is more about end-to-end music. Really, you can input. Well, the advantages is that you can input performance-related content. It's like you know how to play the notes, and basically it is rendered, so you have the full audio. But the issue with this model currently is like you need a very large model to process to generate data. They are not really controllable because you work on the raw signal that mixes all the instruments and all the tracks and all the notes you can play. So the model is not fully aware of what instruments and what track is playing. So it's not really steerable. And also, yeah, you are working on audio and not notes, so you can't change one note if you're inspired or if you want to. So it's not really controllable. So I would say it's there are very, very fun application, and also, for example, for sound design and stuff like this, it's very useful. But I would say currently it's not really suited for the composer workflow. On the contrary, you have symbolic domain generation, which has all the advantages that audio domain hasn't. So basically, it's fully controllable. It's like if you want to modify one note, you can specify really to generate only one track, only one bar of music and stuff like this. It's quite easy to do that. The models are really compact because you are working in a tokenization that really looks like text, in fact. And I would say, and I will demonstrate this, that it fits the artist workflow. We will see that later. Of course, it comes with some drawbacks and limitations, like all models that are very specialized. So it's a simplification of music. So yeah, it's you only have the notes, but you don't have information on how to perform the notes, on what instrument to be played, etc. And finally, if your prompt is an audio file, you will have to convert it to MIDI, so to notation, to score notation beforehand, before generating any music. So it can be a problem. All right. So, in fact, there are different entry points of artificial intelligence in the music composition workflow. So, as I said, I'm really only interested here in how to compose music, not really how to render the instruments and sound design and stuff like this. So, I would say that at least that's my workflow when I am coming to compose some new pieces. Or there are these steps, these obligatory steps I follow. It's like basically you start with an improvisation. So yeah, you go on your keyboard on any instruments and you start to get fresh ideas, stuff like this. Then you have your ideas and you want to compose a song with it. So you put your ideas together, you try to extend it, to develop the ideas and to create a structure that will look like your final piece. After that, you also have an arrangement step that will be like, for example, I may have composed the idea for one instrument, and then I want to orchestrate it with different layers of instruments. I want to arrange it basically. Finally, you go to the performance. It's like you only have note at this stage, and now you want to render the notes with either existing instruments or virtual instruments, VSTs. So you will also go to an humanization step. So maybe you will play around with tempos and stuff like this. And finally, there is a production step, which is very important in music production, because it's a phase where you put all your tracks together and you try to cancel the frequencies that doesn't go together. You have to try to balance the volumes of all tracks, and you also do the mastering. That will give the final color of the song. So at each step of this, you can really use artificial intelligence nowadays to help you. So for improvisation, you have like improvisations copilots that will, for example, memorize your ideas. For example, can extend and play with you in real time. There are composition and arrangement, of course, modules. That's what we are talking about today. And also in the level of at the stage of performance, there are also humanization tricks that are learned some way, or rendering from MIDI that can be learned. And for production, yes, there are many companies that are tackling the issue. But today, and what we are building at MusicLang is basically the step 2 and the step 3 of the music production workflow, which are really developing ideas, extending ideas, and the tracking feelings. That means the arrangement part. All right. So as I said, there are different use cases. So the first use case, I would put it, is song continuation. So I'm a composer, and I have started with a small melody and small arrangement in piano. Here it's Florian from Beethoven. I need to continue this piece. So I need to fill to outpaint the existing score. An useful model should behave in a certain way. For example, it should understand the difference between instruments. It should know that a piano is not played like a harp, it's not played like a flute and stuff like this. It should handle quite long context, because you want the ideas to be repeated through the pieces. You want some structure in the way the transformer will make the music. You want it also to catch the intended composition style. It's like just a basic coherence of the output you have. And finally, to be useful, it's not only that it should be of high quality generation, it also must be somehow very controllable. It's like if I want a specific color, if I want a specific rhythm, I want specific constraints, I should be able to input it. So that's very hard constraints. There is also a second use case, which I find also very interesting for the composition workflow, is the arrangement copilot. I call it like that. It's for example, I've developed a melody I'm proud of. Here it's the melody from the Mario Bros 10, I guess. I want to add, for example, a piano track, a drum track to accompany my melody. So the constraint for this kind of model is a little bit different. Here, for example, you want to predict using all the available bar of the context. You don't want to just predict what's coming next, but really what is coming with the current music. And you have to understand the difference. Of course, still you understand the difference between instruments, and also the output should be controllable, but in a kind of different way. So in these two use cases, in fact, the models that will be used are somewhat different because on the first case, you have like a purely autoregressive model. It's like you input your MIDI file, you tokenize it, and then you want to predict what's coming next, basically. So the prompt is made with the same materials and the generation. And the context size, what is used by the model is really given by the limit of token of your model. So for open source model, for example, it's 4K tokens. It is different than our arrangement copilot model, because the arrangement is really, you have to see it like really an in-painting model. It's very looking like a diffusion model, for example, an in-painting model, sorry, from image generation. So you select a part of your image and you want to input a text and to replace what is selected. So there are really a logic separation between the prompt with the mask and the infilling generation. For the context, you have to decide and to really process your training data in a way to fix your context size. So this model won't be able to generate like infinite duration music. They will be focusing on really a fixed context size. For example, a maximum of 16 bars, I would say. But you can go from 1 bar to 16 bars. So that's the two different models. And at MusicLang, so we have released 3 weeks ago some continuation model. Our first continuation model that is completely open source to use. So let's describe a little more what architecture we used. So it is based on Llama 2 architecture. So it's not a fine tune from Llama or anything else. It's just the architecture we kept, because of course the tokenization has nothing is really different from text. The training and inference are inspired by Andrej Karpathy Llama 2.c, which is an open source project that is providing a training and inference code for this architecture, this specific architecture. And so you have especially, and we worked also a lot about that, to integrate its optimized inference for CPU, because we are working with relatively small language models. So we found it very useful to be able to predict it on any laptop. So by optimizing for CPU basically. So it's, as I said, it's relatively small. Talking about 60 million parameters, about 12 layers, 12 attention head, and 600 magnetic size. And the context window is quite large, as I said. You can approximately do 2 minutes of music at a normal tempo with, for example, three different instruments, really different instrument tracks. And also we use byte pair encoding, which is a state of the art for this kind of models to compress the vocabulary. Finally, in music, it's very important to talk about the training data. So we are trying to be really transparent about that. So currently we are using all our training data. All our training data is the LAKH dataset that you can find in the available link. So it's a CC40 commercial free license. So it's composed of basically 200,000 MIDI file. And we use that for the training. You can check on our GitHub, and I won't go in details about the examples here. We will probably do. It will be probably better if I just make you hear some music. But you can use the package easily. So it's a Python package you can install, and then you can directly use it for predicting a certain level of token. So you have different use case on the continuation model. You have first a free generations, like you don't have any prompt and you just want to generate free music. You can do that like that. You have also some constraints implementations. For example, you can input a chord progression, and you can ask the model to generate music that fits this particular chord progression. With the approximations that one chord will be 1 bar of music. It's encoded in the model like this. And you can, of course, control many other parameters standard to this kind of model, for example, the temperature and the number of tokens generated. And you can choose the rhythmic modality, so time signature, basically. And finally, the third use case, which can be very interesting, is that you have an existing piece of music you composed, and now you want an extension of this music, but following your own harmonic constraints. It's like you say which chord you want, and then it will try to fit that. All right. So maybe I will answer two questions if there are really specific questions about the tokenization and stuff like this. So let's keep maybe that for later. Here I'm summarizing some interesting links you can use. So we have our GitHub repositories that you can access, and you can install our open source package from here. We have a technical blog, and you will find many generated song example and some documentation about how the tokenizer works, basically. We also had some first contributors from the communities that played around with MusicLang. For example, there is a Twitch channel, which is a Twitch bot that generates music depending of what people are inputting on the chat. And we also have a YouTube channel where we will post music generated with MusicLang regularly by people that are using MusicLang and stuff like this. And finally, you have our Hugging Face model. All right, so we will do a demo in two parts. So let's hear some music. So first, I will do some song continuation. So let's spend 5 minutes to hear some music, I would say. So first use case, as I said, is the open source song continuation model. We'll do some different use cases. And then you will also see a project that we are developing at MusicLang, which will come into an API at some point. It is really the arrangement copilot, which we find is a tangible artist interaction with a composition assistant. Okay, so let's go. So here I'm generating a free generation, which is the first use case. So I didn't give any constraint to the system. I let the system generate, and then I rendered the output with VST instruments, but of course without touching the music. And the examples are quite long, so I will do a quick extract of them. All right, so yeah, let's keep it to 30 seconds maybe. Another example, so you can generate in very many different styles. So for example, here's the generations that lead to a jazz kind of vibe. We also have, for example, pop rock generation. All right. So that's where free generations that you can find on all the examples are available on our technical blog anyway. There is also a song continuation. Using the same model, you can also perform some song continuation. So here I've tried to use some famous music, for example, the free release from Beethoven that we can. So you will hear the first 4 bars will be the real music, and then we will ask MusicLang to continue the music. So it starts here. All right, so here you have an example of a sentence outputted by the model. Let's try another one. For example, the famous Alla Turca from Mozart, which is also a single instrument. We will go to orchestral music afterward. And finally, yeah, let's do a theme from Rayman, which was my favorite game when I was younger. So it was a theme from Bandland, which is a level. All right, so it gave like a techno vibe on the original song. Okay, so and finally we have our last use case. So here we just have an existing chord progression. For example, we took the progression from the main theme of Zelda, and we let MusicLang generate a music that follows this chord progression. So maybe if you're familiar with the theme, you will recognize this famous chord progression. Okay. So here we also let the model choose the instruments it wanted. So we only condition it on chord progression. Maybe I will do like a last example. For example, let's take a famous song, so go Creep from Radiohead, because the chord progression is very obvious. So let's try what it gave. Okay. Okay, cool. So, okay, as I said, our example you can find on the technical blog. And finally, I will finish with that. Probably, we also have like a different kind of model, as I was speaking, the arranging copilot. So it's more a masking model. So you will see the use case here, and the video is available on YouTube. Okay, so you saw the different kind of model. It's here. It's more about in painting. It's like you have an existing music and you want to add some tracks with the music. We have to finish. We have a roadmap. So for MusicLang, for the company. So we will continue about song continuation model, and we might release some new features on the open source model also. So for example, for instrument controls, for density of note controls, and for controlling the polyphony of notes. And finally, for larger models that are not still open source, we will also give an API for you to test some use case. On the other side, we have the arrangement copilot models, and the same here. We are trying to furnish new API that will solve the use case you saw just on the last video. Okay, so that will be all from my presentation. So feel free to ask me any question.
That was incredible. I'd be like, whoa, we're looking at the future right now. I have a couple questions that I will ask right now, and then we'll open it up to the rest of the community. So first one is, how is MusicLang compared to something like Suno AI?
Yeah, so MusicLang is we are trying to be really different from this kind of companies because we are not furnishing a service for like everyone to use it to generate any background music or stuff like this. We are really focusing on providing values for artists. And so that's why we are not targeting to release like, for example, an app where you can generate music and stuff like this, but really to integrate into already existing music tech products that will be helpful for artists. So we are really specialized in terms of company. We are really specialized of making great models, but we are not experts in any way into developing complicated software and stuff like this. And we also are really focused about targeting artists and to enter the workflow of artists. For example, because you mentioned Suno, it's a little bit different because they are not targeting directly the artists, but really, yeah.
Cool. So it sounds like MusicLang is more for like trained musicians as opposed to like tools like Suno AI, which is for like the rest of us just generating like dumb music. That's like just kind of continues for like with no like rhythms or patterns and stuff like that. So that makes sense.
It's different customer base. Yeah.
Yeah. So when you talk about like simplification of music, when you talked about symbolic domain generation, what does that actually mean?
Yeah. So I talked about simplification because it's true. It's like you have when you hear music, it's this very complicated signal that has been engineered with many signal processing tools that have been rendered with potentially professional players that are performing the music. So you have that in the audio models, but of course, as soon as you go to the symbolic domain, you lose that because you are not working anymore with sound. You're working with a score, like any sheet music you would use. So you lose, all the notes were rendered, maybe some humanization feel about how it was exactly played on your instruments and stuff like this. Because we can't notate everything, we are quite forced to do simplification. But this simplification is not necessarily a drawback because, as I said, we are trying to fit in the artist workflow. And usually the steps of composing the music, which is quite, very theoretical and stuff like this, and the performing of music, it's really a different step for the artist usually. So it can be different, of course. Each artist is different, but that can be factorized.
Okay, that makes sense. How is MusicLang based on Llama 2 architecture? Can you just give me, like, explain to me like I'm 5? Like, how does that work? Because one is I'm used to like the text, format, and now we're talking in the music realm, which I have no experience in. So you gotta explain to me like I'm like a beginner.
Yeah, sure. So Llama 2 first, as I mentioned, for me, it's not the models that generate text. For me, it's really the architecture. It's like you have this toolbox that allow you to train my machine learning models. So we used this Llama 2 architecture, and so it accepts in input, it accepts something like that looks like text. But you can, in some sense, you can cheat. You are not forced to input really text. You can input music that has been processed as text. So in our case, so we don't use a character. We use like tokens of music that represent, for example, I have a specific note at this specific time. I will input it to the Llama 2 architecture as it were a token of text. So that's how we are using the model. But as I said, we are not using any fine tuning of the model or stuff like this. We are really taking the raw architecture because it works very well, and we are training on our own process data.
Okay, so you kind of touched on like prompting with music tokenization as opposed to text tokenization here. So can you just dive into like the prompting part a little bit, especially maybe use the example of like music continuation. It's like you're trying to continue that short snippet of Creep by Radiohead. It's like, how did you like prompt it to continue?
Yeah, so yeah, for this use case, it was not continuing, it was generating the same chord progression. So it was not using the prompt of Radiohead before, but anyway, it's not really a problem. So so in fact, when you can't directly prompt to the model, for example, the audio file of Radiohead Creep, it won't work like that. It's a little bit more complicated. We work on the symbolic domain, as I said. So we work with what we call MIDI files. It's basically a file that represents, in some sense, a score. So it tells you what the notes are played and by which instruments and when. So it is really the input of the model. So if you wanted to use Radiohead Creep as a WAV file, as a really audio file, and input it into MusicLang, you will need an intermediary step to convert it into a score. So you will make a transcription. It's like you say, yeah. And then you can use you can use our model. But it's as I said, because we are not really focusing on this end-to-end use case, we are focusing on a use case where artists already are dealing with MIDI source scores. So it's also not a problem for us.
Gotcha. So it's more about like the MIDI file format as opposed to like regular text tokenization, right?
Yeah.
Okay. So last question, 4,000 tokens on context window. Do you find that to be enough for most songs, or is that something that you're trying to expand more?
Yeah, that would be good to expand. It's depending on the use case. In fact, because as I said, we have two models, like the continuation and the masking, the in-painting model. And the contexts are used very differently. So currently, yeah, you have a limitation. It's like if you take a song, it will be maximum like 2 minutes of music. It can be enough for a lot of application and for a lot of music generated. But of course, yeah, we have planned to work on this domain. For the other use case, which is more about in painting, we are really also looking to extend the context size, so maybe using 32 bars of music or stuff like this. But because we are not generating full music, we are just here in an iterative process. It's like the artist will input a melody, then he will ask the model to complete new tracks or to correct some bars of music. It's not necessarily a big problem that we don't have an infinite size context, because the artist will provide also the context by himself and do the correction. We are really a copilot, and that's our goal.
Awesome. Thank you. So now the floor is open to anybody. Does anyone have any questions they want to ask? All right, don't be shy. Just unmute yourself.
I can go ahead. Thank you so much, Florian, for the great presentation, and it was very intriguing for me as just enthusiastic. I wonder about the use case for the actually not the use case, but how do you implement it with the artist? For example, how do you license it since it's for open source? Are you charging them in some way, or are they paying for application, or what will be the strategy?
Yeah. So yeah, we are a company, so we have a business model behind it, but we have really separated the open source part and the enterprise stuff. So in open source, you can use our model any way you want. Just the code, the prediction is JPL. So if you do some modification, you have to put it, but the model is okay. So this is a model you can use for some continuation use case. So you don't really need to worry about that. But we also have other models that we have a larger and more accurate model for some continuation. That's the first part, and also with more controllable. For example, with you can control the instruments, you can control the quality of melodies and stuff like this. That's the first part. And we also have, when interviewing many artists recently, we also have another use case. That's the second model I was talking about, which was from the video. the in painting models, and this one is not we don't release an open source model yet, so it will function like an API. So if you have a use case in your music tech software, basically you will need to call this API. So that's our business model.
Yeah, merci, Florian. And just one follow-up question: have you done recently any collaboration with any artists, or is it a bit early?
Yeah, it's quite a bit early. We are really in discussion, but we didn't release anything serious yet. But yeah, it will no spoiler, but it will come.
Yeah, thanks, Mars. Thanks.
Anybody else? All right. So thanks, Gabe. Well, do you want to ask any questions? Hop on the call or? Okay, sounds great. So Florian, how can people find you and find out more about the project? Oh, and
Yeah,
that's a question. There too. My bad. Where do you see MusicLang in 5 years? That's what Gabe asked.
Oh. So we see ourselves like the main generative AI model provider for music industry. Simple as that.
Cool.
And so your question was where you can find us. So maybe if I still sharing my screen, I have some link. So that's our test link right now. It's like we have our open source package that you can find here, our technical blog, and I'm forgetting that we also have our main website, which is just musiclang.io. So yeah, if you want to find us, you can go from there. But don't hesitate if you have any use case or interesting stuff to share with us. You can contact me, of course, on LinkedIn. I will be glad to answer.
And we have a Discord channel as well.
Yeah.
If you guys have any question or if you need some support, yeah, happy to help.
Awesome. Well, thank you for sharing this awesome project with us. We're AI Tinkers in Ottawa. I think that's it. That's the webinar. So you're all for coming.